So let us continue. This is the same slide like last week. Okay, we stopped somehow in the data models. So last week, you learned and I introduced to you the data model. So what are the data model? It is an abstraction of a complex real world data environment. It means that in simple words, data comes from object. Okay, so we recognize the object as an entity under the relational model. Okay, and these are the four five basic data modeling components, including entities, attribute, relationship, and also the constraint. But importantly, you need to understand these three entities. Sorry, the three components that builds data modeling. Entities, object, okay. The attributes, the features belongs to the entities, and also the relationship. How do they relate from one to another object or entities? And then how do we convert from or transform the real world data, so-called data, to become a data model. So we use the business rules method. Okay, business rule is a statement that represents the real world situation. Okay, but what are they present? They present the connection. Usually, what is the connection between two objects, okay, or two entities in simple words. So business rule is used to identify and define the basic modeling components. So please remember the business rules process. Okay, a student enrolled to many courses. Okay, one courses is enrolled by many number of students. So that is the example of a business rule. So we use this statement and then we develop data models. Okay, models for that data. Okay, and then we have hierarchical. This is a data models type. Data model type. Okay, types. We have hierarchical, network, relational, object oriented. Okay, and in the following we also have object relational, entity relational, extended relational data model. Okay, and but from now on in this class we focus on the relational model. Okay, relational model. So this is commonly used. Then the ER model is a tool for modeling that is complement with the relational model. So the naming for relational model is closely related with these entities, attributes, and also the relationship. Later on, you will know why it is named as a relational. Why? A relational model. Okay. Right. So this week, okay, we go more focus on the one of the data modeling type, that is a relational data model. Okay, so it falls under the category of relational database. Remember, in second or third generation relational database. Okay, and when we are in the relational database, the modeling itself is named as a relational data model. Okay, relational data model. So in this part, you will learn about the relational data model, terminology of relational model, how tables, okay, I used to represent the data, the connection between the mathematical relation, okay, I bring this forward, and then properties of data relation, how to define primary key, okay, foreign key, and then meaning of integrity, referential integrity, and the views. Okay, the views. So sometimes you will learn this topic in this chapter, and the other chapter is reintroduce back again. So somehow for example, the terminology I already explained, or you already heard in my first chapter, and then the last week, okay, some terminology has been introduced. So why relational model? So this is the most widely used in the world, widely used model. So the popular vendors that work under the relational model is like Oracle, okay, Oracle, IBM long before Informix, Microsoft, Sybase, and so on. So this is a large giant organization that work with this relational model. Okay, so this is a legacy system in older model, IBMs. Okay, but the recent competitor for the relational model is object-oriented, not too recent. Okay, object store version onto system organization, and now object-oriented model has emerged, and they have their own success story. Okay, and with their advantages, okay, of their model. But these two target is the same, okay, to manage the database, to provide the advantage of a database, okay, but they have a different way, different standard, and so on. But if we look carefully, their basic is like a same, but they do have a different and extended features of each other. Okay, so relational database definition. It is a set of relations, So when we talk about a set, okay, so it goes to the mathematics, and relation also goes to the relations theory. So we can say that the database is a kind of mathematics applications. Okay, so this is where one example that mathematics is used and applied in the computer science, IT. So a relational database is a type of database that stores and provides access to data points that are related to one another. Okay, it's a type of a database. And then relational database are based on the relational model. So remember, what is this relational database and model? Okay, again, remember logical and physical. Okay, physical. So usually we always start with the modeling, okay, model, then we transfer to the real. The real one is the database. Okay, so this is what they mean by the relational database, which are based on the relational model. Okay, it is a straightforward way of representing data in tables. They represent the data in a table. This is what we already learned last week. Okay, and each row in the table is a record with a unique ID called the key. So the key is a unique ID. We have several types of keys. Okay, later on we will learn about this. But the most important is the main unique ID that is used to recognize, okay, the set of rows that is a primary key. So the columns then in the table holds the attributes of the data. So this is the same explanation. A table contains columns and also rows. Okay, rows or tuple. This one is an attributes. Okay, and the set of this one is named as a relation or table. Okay, so this is the model of the relational data. Okay, so relation made up of two parts. The first one is an instance set of records. Okay, and the second one is a schema. Second one is a schema. Instance is a set of records that is a table with rows and columns. Now they have a new name. Rows mention the cardinality, and the attributes or column mention the degree of arity. So fields are the same as a column or attributes. Okay, so this is the example. Okay, we find that this relation or this table contains arity of 3 and cardinality of 4. Okay, so arity is a column. Okay, column, and cardinality is a rows. Okay, rows or records. Okay, so you need to remember this one. Arity is a degree of a relation. Meanwhile, the cardinality of relation is defined as a number of tuples in the relation. Arity and cardinality. Okay. The other, this is a one part, this is instance, and second one is a schema. Okay, last week I already explained to you how do we write a schema. So schema give us the information of a table, okay, with its attributes. It is actually another representation of table form. Another representation. Okay, we do write schema in this way. This is one form, and the other one is like this. Students. Okay, you can write in this form like, sorry, table like representations. Usually we use this one. Okay, and we extend the information in the schema by mentioning the data types also, and it can grow large. Okay, using this type of schema. So I hope you're clear when we say that it's a schema data or schema table. Then you should write in this way, either one. But sometimes it is specifically mentioned which form you need to write. Okay. Again, it is an instance containing the rows and also the attributes. And the other one is a schema, a specified name of relation plus name and domain of each field. The domain is actually the column or attributes. Okay, now you can see that for one components, they have multiple names. We have like this, attributes or columns. Okay, columns. Then numbers of it is known as an arity. And then for this part, okay, this the number we have is known as a cardinality. Okay, this one is rows or tuple or records. Okay, multiple. So you need to quickly identify which is which. So it is not wrong to use the naming for this one. Okay, right. Example, instance of students relation. So this is a student relation. Sometimes we do not name it as a, sorry, we do not call it as a table. We do not say table student. We say student relations. Okay, student relations. So you need to capture the meaning behind it, that is student table. Okay, student table. So for this example, so you can see that we have cardinality 3 and degree or arity is 5. Okay, arity column. Okay, and all rows are distinct in this case. Distinct in this case. Schema versus instances. Okay, previously we introduced, we have two types of this one. The first one is instance and second one is a schema. So for the database schema, it gives us this description of a database. Okay, because it gives us a data structure, the data types, and also the constraint on the database. Okay, somehow we also use a schema diagram, but we rarely use that one. And a schema can construct like this, as a component of the schema or an object with the schema like this. Okay, but usually we only use the previous form, okay, of a schema to represent its value. Okay. Right. And we also have a database state. So the database state is the actual data stored in a database at a particular moment in time. We know, we understand that information in the database keep changing, okay? Because new data comes in, new data obsolete, new data is updated, and so on, and it keeps change. Okay, so that's why we have a situation named as a database state. This is to capture the information, what is the condition or what is the situation of database in that mentioned state. Okay, so this is also called as a database instance or occurrence or snapshot. So the term instance is also applied to individual database like record instance, table, and also the entity instance. Okay, so again, database state refers to the content of a database at a moment in time. For example, now, okay, our attendance is like this. But 10 minutes before, our attendance, our class attendance is different, like now. Okay, so this is the situation of a database state. Okay. So the rest is the particular regarding the database state, that is initial database state and also the valid state. Okay. So what sometimes this I need to introduce to you various particulars, various situation or preference, condition, and so on of the database. Somehow it is very much important to know, but some of information is for the knowledge purpose only. Okay. Distinction. Okay. The database schema changes very infrequently. Okay. But the database state changes every time the database is updated. So this is a difference between the schema and also state. Okay, schema, we rarely change the schema actually. So not always change what is mean. Okay, but it's different with the state. Yeah, state because state involve the content of the database created, so it may frequently change depending on the situation of the database itself. So schema is also known as an intention, and also the state is also called as extension. Okay, schema and also the state. Okay, schema is like what standard? No. Is like a template, template given for specific table or entities. Okay? While state is the situation. What do they have at that particular moment of time? Okay? So this is an example of database schema. If you are required, if you are given this kind of schema, and then rewrite the schema in another form, and then you can write it. Okay, in another form. For example, like this, student name, student number, class, major, and so on. But this is a simplest schema without primary key, without key declaration, without the data type declaration, and so on. Okay, so from this, you can see that this is maybe about a database for the student. Okay, we have a student table, course table, prerequisite, section, and grade report. So from now on, this is what you can see. Okay, and we will work more on this part. Okay. So this is a database schema. Why database schema? Because they have multiple. This one. In the last week, I said one particular schema is known as a data schema, right? Remember? Data schema. But if we have multiple and we can group it in one category, okay? So now it's known as a database schema. Database schema. Because all of these belongs to one specific database. Okay. So this is another example showing a database state. At that time, the information is like this. Okay, for example, now, okay, now the content of this schema database is like this. But it may change after 10 minutes, after 1 hour, after 1 day, and so on. Of course, because a new data comes in, goes out, and some needs changes. Okay, so this is a database state. Right. So we go back to the relational model. Okay, developed by F. 1970. Some says some book says 1969. Okay, they explain data in a table relation. So it is a matrix consisting of a row or column intersection. So in simple word, it's a table. A table construct from the row and column, two-dimensional, and each row in a relation is called a tuple. So at that time, they said that this model is impractical, okay, because maybe model was conceptually in simple at expense of computer overhead. This is something to do with the machine and so on. Then they do some improvement, and a relational data management system is introduced. They perform same function provided by hierarchical model, but they hide the complexity from the user. Here they have also introduced the relational diagram. Relational diagram that stores information they represent it in the diagrams which contains the entities, attributes, and also relationship. So this is the early idea of relational model. They have the entities, okay, and also the relationship. This is relationship, and they do contain the attributes inside. Okay, so this is the relational model. And at that time also SQL is invented, and this is based on the relational database application. Okay, SQL, they have the user interface. Because SQL is not only offers the language, they do have also the software. So they have the user interface to allow the interaction between the users. And then, of course, they have a set of tables stored in the database, and also the engine. They need engine to execute all the queries. Maybe some of you did not understand yet what is the queries. Okay, remember that now you are in a phase of data definition. Okay, you define the student. You define the table. Okay, so this is, for example, table for student with several attributes: ID, name, age, for example. So then this is a data definition. You define the structure, you define the model, and then you develop the database inside the DBMS. Okay, now you have this one. And remember, during the practical session, you input the data inside it. Okay, for example, ID1, name, Ali, okay, age 21, okay, to Abu, age 20. So now you start to insert the table, insert the data to the tables, right? So you insert in table this, you insert data to table that, and then or you update the data you insert, or you delete, remove the data, and here and that. Okay, so this is the activities. Then after you keep the data in the table or in the database itself, then what? So what? After we keep, then we want to retrieve back, right? Sometimes we need to retrieve it back. So retrieving the data from the database needs query. Okay, needs a query. Okay, for example, please show me or please find me the student's name Ali. Is that student is in the data or not? So we use the query. So the query, when we say the query, the most popular code is named as a select. Okay, select all, everything. Okay, from table student. Okay, like this. So they will display. Okay, the software will give you a listing what are inside the table student. Now is the time for you to query them, and then they give you the answer. So it needs an engine. So like you are browsing information from the browser. Okay, so this is the input text, and then you give some keywords. Okay, give me the definition of DBMS. Okay, and then the engine will find more find information and list it to you. So the activity, the process is actually you querying to the engine. Okay, sorry, querying to the browser, and the browser will go crawling and search from the database and then give back. So its searching engine will give back the result to the user or the person who asked the question. Okay, question. So it's the same situation like this. Query. Okay, so they need the information, the engine to search. Okay, the information that is required by the user. Okay, right. In opposite of relational, okay, we have also the object-oriented model. Object-oriented. So apart from relational, we have the object OO model. So data and relationship are contained in a single structure known as an object. Now here in OO model, the entity is known as an object. It's very easy to remember the code. OODM is the basis of OODBMS. Okay, we have relational database. Then the DBMS is RDBMS. And for the object-oriented database, they have the OODBMS. Okay, that means that the software provides the structure or standard based on what model? Relational or object-oriented. So an object contains operation, okay, a self-contained, and also is an abstraction of real-world entity. So the definition of an object is similar like you learned during the object-oriented programming class. Okay, object-oriented, the same. Okay, it has an operation. Okay, and then the features, it is self-contained, and also it is an abstraction of a real-world object entity. Attributes here describe the properties of an object. This is the same. Object that share similar characteristics are grouped in classes. We have a larger object named as a classes, where they group several similar objects in a single class. Classes then are organized in a class hierarchy, and they do have a property of inheritance. That is, the object inherits methods and attributes of a parent class. Okay, and UML is based on the object-oriented concept. Okay, so this is the glass rule of the object-oriented model. The definition is the same, whether it is in database or whether it is in the system development or whether it is in the programming. The definition is same, consistent. Okay, the features like the abstraction, like the inheritance, and what's more, polymorphism. Okay, so this is the same, the concept. Okay, so now you can see the comparison of object-oriented, okay, UML and also ER model. Okay. You know, right, how to write the UML. Okay, so they look alike. They look alike. Okay, they have object name. This is a table name or relation name. And then they have the like relation. So this is a relation. They also have, okay, and then they have the connection. Okay, many to many, one to many, the same, almost the same. But what differs? One, the way we read it, and then second is operation. Yeah, ER model does not have operation, but this one they have the operation, right? They have the operation or functions. Okay, so this is different between UML and also ER model. Okay, class not UML, sorry, class diagram and ER model. Okay, so this is important for you to understand this too. Okay, during your final year project, you need to identify which method, which approach you will take. Whether your product, you are designing your system or application under the object-oriented structure, object-oriented method approach, or under the structured approach. So if you are using the object-oriented approach, then you will go in this path. Okay, you have a class diagram, and then you have UML use cases. What else? Sequence diagram, activity diagram, and so on. So this is the path. If you are doing a project based on the structured approach, then you will need to create the ER model, and then for the functions, you are required to draw the DFD, okay, data flow diagram. Okay, so this is what is this actually? What is this? Representation, the diagram, and so on. So all of these are a design. Okay, it's a design. Before you go to the coding, before you go to directly to the DBMS, you need to do the design. And from where design coming from? From where? You need the real situation, right? Real situation. Okay, and then you transform the information you observe from the real situation to this design. This design. Then finally, you can go to your software, DBMS, to develop a physical system or database. Okay, this is, we have a business rule here. Okay, so this is the cycle, Okay, so I do relate what you learn from other class. Okay, what is the relation? Why you need to study the database? Why you need to study the SAD? Okay, why do you need to study the programming and so on? So this is the circle. Okay, and also the cycle. All right. So we go back to the entity relationship model. It is widely accepted model. This is model. So widely accepted standard for data modeling, introduced by Chen, 1976. Okay, graphical representation of entities and their relationship. When we talk about the model, usually they come up with the graphical representation. So we need to draw the diagram. So what is the diagram? So that the diagram is namely as a entity relationship diagram. Okay, entity relationship diagram. So 1970s, okay, they introduce the relational model, relational database. Okay, and 1976 they come up with the modeling of entity relationship in the ERM. Okay, and when they do need the diagramming or graphical representation, okay, to help the person to draw, not draw, to design the relational database. So they come up with the entity relationship diagram, ERD, what we use until now, okay, from 1976 until present. It uses a graphic representation to model database components, and entity is mapped to a relational table. Okay, like this. So from this, you can see that we have two types or two models that we can draw our ERD. Okay, you can select either chain notation or Crowfoot notation. But this one is more preferable, okay, because it's more compact and cozy. Okay, remember the chain notation, we have these entities, rectangle give us the entities, and the connector of relationship made by a diamond. Okay, painter paints painting, one painter paints painting. So that what is this? Business rule, kan? Business rule. Okay. An employee can learn many skills. So each skill can be learned by many employees, and then employees manage one store. Each store is managed by one employee. Okay. So in the perspective or in the view of assessment, quiz or test or examination, they may give you, the question may give you this ERD diagram, and then you are required to draw the, write the business rule. Or you are given a business rule, then you are required to draw the ER diagram. Maybe they want a specific chain, using chain method or using a Crowfoot method. If it is not mentioned, then you can choose either one. Okay, so this is from the perspective of assessment or examination. Okay, they give you the business rule statement, you are required to draw the diagram or given a diagram, then write down the statement. Okay, the business rule. Right. Okay, so next week you are going to go further with this diagramming, and then the situation, like given a situation or story, then you need to identify what are the attributes, what are the objects or entities, what are the relation, and then do a design by ER. Okay, so terminology. Important to understand this one. A relation is a table. Again, a relation is a table with columns and rows. Okay. Attribute is a name column of relation. Domain is the set of allowable values for one or more attributes. Tuple is a row of a relation. Degree is the number of attributes in a relation. What degree? Arity kan tadi. Okay. And then cardinality is the number of a tuple in a relation. So go back like this. This is a relation, is a table with columns and rows. Okay, this is a relation. This is the columns, attributes. Okay, and this is a tuple. The value inside this one can be also understand by this word domain, but usually we name it as only a data. Okay, this is a tuple, number of row or records. Okay, and the number of it is named as a degree or arity. Okay, and number of attributes, okay, is known as a cardinality. Cardinality, number of attributes. This is degree or arity, number of attributes. Sorry, cardinality is number of tuples. Balik ni. And degree is a number of attributes in a relation. Okay, sorry. Okay, this one. This one, degree or arity, and this one is a cardinality. Cardinality. Okay, so this is a few terminology or jargons under this relational table. Many more will come. Okay, and relational database is a collection of normalized relation with distinct. Okay, and you see the wording here, normalize. Normalize. So we also have database normalization. Okay, later on we will study about this one also. Okay, look at this. The question maybe ask you, give you like this, and then draw the ER. Can from this, you transfer this one into the ER. Okay, actually it comes from the ER, but they can just reverse thing. Okay, so draw the ER diagram for this relation. Okay, so you need to draw the ER. This branch. Okay, this one is stuff. Okay, then you need to identify the relation. Okay, and give the attributes. Write down the attributes and so on. Okay, give a primary key and so on. Okay, this is an example of a relation, branch and also staff relation. The branch will be assigned. Okay, so you understand this, and this is many to many or one to many, so it goes back to the situation they have. Okay. This is an example of attribute domains. So the domains name attribute is branch number. The domain name is a branch numbers, the meaning and domain definition. So the ranges of value that can be included or that can be inserted into a defined attribute. Okay. Formal term. Okay, formal terms. Alternative 1, alternative 2. So this is what I mean. For one definition, for one name, we have multiple naming. Okay, like a relation, they also known as a table, they also known as a file, or for the tuple, they also known as a row, they also known as a record, and for attribute, they also known as a column, and also the field. You can select either one, but make sure it is consistent. If you use relation, then followed by the tuple and also the attributes. And then if you use a table, usually we use a row on column. Okay, the same goes to the file, record, and field. This is a bigger situation. Okay, this is a student name. Student relation. Okay, so this is actually the table name, student. They have attributes with 1, 2, 3, 4, 5, 6, 7 degrees, right? 7 degree. And then tuples here, they have 5, 6, 5. Okay, 5 cardinality. Okay. So from this, what attribute may be a primary key? This one can be upgraded to the primary Okay, primary key. The key that must be unique and identifiable when it is searched. Okay, database relation. Relation schema is a name a relation defined by a set of attribute. I think this is a repeated definition. Okay, and then properties of relation. Relation name must be distinct from all other relation names in relational schema. Usually in one single database. Okay, for example, this is a university database. We have a student, right? Student table. Okay, course, lecturer, program, and so on, right? Okay, but we rarely have another table named the same, like this. Okay, so they guide us that the relation name must be distinct from all other relation. Okay, and each cell of relation contains exactly one atomic single value. Each cell. For example, this is Ali, this is Abu. Okay, this is actually exactly one atomic single value. Okay, and each attribute should has a distinct name. So again, we cannot have name and name. Cannot. Okay, but the one that is allowed is this is a first name, this one is last name. This is okay because they give a different definition. Okay, values of an attribute are all from the same domains. Same domain. Values of an attribute. Values. This is values. Okay, the data goes inside is a values, and then they ask that it must came from the same domain. Okay, each tuple is distinct. There are no duplicate tuples. Order of attributes has no significance. Order of tuple also has no significance theoretically. Okay. This one they allow a duplicate actually because sometimes we do have a duplicate, but we need to reduce the duplication in the data. Somehow we cannot escape from the data duplication in some cases. Okay. Integrity constraints. Okay. We have several types of integrity constraints. One of it is entity integrity. Second is referential integrity. And then we have also the general constraints. Remember previously, the constraint you understand from the practical exercise. We have we define constraint like not null, right? Not null. So this is one type of the constraint. So in the entity integrity, in a base relation, no attribute of a primary key can be null. No attribute of a primary key can be null. Means that primary key cannot null. Okay, cannot have null value. It must have a value and it must unique. Okay. Then referential integrity. If foreign key exists in a relation, either foreign key value must match a candidate key value of some tuple in its home relation, or foreign key value must be wholly null. So this is the situation. Foreign key. Okay. Remember foreign key. So this is student. This is a course. Okay, this is a student ID, name, age, course ID, then course name, course lecturer, for example. Okay, if foreign key exists, okay, this is a primary key, right? This is a primary key. Student ID is a primary key in the table student, and course ID is a primary key in the course table. Okay. Now they do not have any relation, but then we want to have a relation that a student enroll or register. Okay. Many students register for many course in this case. Okay. So when we do like this, we want to connect this one. Okay, this is a primary key. When we bring the student ID into the course table, then here student ID will become a foreign key. Foreign key in another table. So for the referential integrity, if foreign key exists in a relation, either foreign key value must match a candidate key value of some tuple in its home relation, or foreign key must be wholly null. Either the value here is null, or it should follow the value for the candidate key value. Candidate key, like other key, they have in table, they can have multiple key, okay, but only one can be primary key. So the rest is a candidate key. Okay? This is the situation of referential integrity. Then next is a general constraints. Additional rules specified by users or database administrator that define or constrain some aspect of the enterprise. This is very general. Maybe they want to include the some values that is constrained from entered to the database, or the situation okay, cannot be entered to the database. So this is very generic to the situation. Okay, let's do some exercise. We have here is schema, database schema for hotel, I guess, hotel booking. Okay, we have schema 1, hotel number, hotel name, city, then room number, hotel number, city, and so on, booking, and also the guest. So the question is, identify primary key and foreign key in the schema table. Can you identify the primary key? For the hotel, primary key will be hotel number, right? So this is a primary key. And then room number. Hotel name. It can be a primary key? No. It can be a candidate key? Cannot, because hotel name cannot. Hotel name is not unique actually. Okay, they can have a same name. Okay, and also the city. We can have the same similar city name. Okay, so it cannot be a key. Okay, we go to the second room. Room number can be a primary key. How about the hotel number? Is this a primary key? Hotel number. Anyone?
No.
No. So what is that?
It's a foreign key.
Yes, it's a foreign key because hotel number does not belong to the object or entity room. One thing. And second thing, hotel number is already declared to another table. That is a hotel. And it is a primary key in the hotel table. So when we bring it to another table, so now it is a foreign key. Type, no. Price, no. This is a normal. It's a normal attributes. Booking, hotel number, guest number. Okay. What is this? Can you guess? Hotel number. Is this a foreign key? Guest number?
I think it's primary key.
Primary key? Hotel number, primary key. So this is another situation. Okay, for the booking, usually we use a booking number, right? So in simple definition, we can declare booking ID or booking number as a primary key. Simple, right? But in this case, they do not give that one. So they have the hotel number and guest number. But hotel number is belong to the hotel and guest number belong to guest table. Okay. So in this case, they may have two attributes, two keys that will become their primary key. So these two will become the primary key for the booking table. Okay. Date to a room number. Room number is a foreign key. All right. Guest number, primary key, guest name, guest address. Okay, so this is one definition. Yes, maybe you are querying, is there a situation that we can have multiple attribute as a primary key? Yes, we have usually two, okay, primary key as a primary key. Okay, this is something to do with the hotel situation. Okay, hotel, a room, booking, guest. Okay, hotel database. Okay, this is the guest book room. Right, so this is the ER, guest book room. So what are the relation? Okay, so guest, many guests book many room. Can be, right? The situation we have one guest book one room, one guest can book many room, multiple room. Okay, and we can also have many guests book many room in general. So when we have this one, many to many, we need to remove the many to many situation. So this is about the data normalization. Okay, so that's why they have a booking. So when they do the normalization, okay, to convert many to many to one to many, okay, so they come up with guest booking, okay, and also the room. So this is the original table, and the book is now, the relation book is now is updated to the new table booking. So booking, here they have a guest number, and here room number. Okay, so they can take these two primary key from other connecting table to become a primary key in the new created table. Okay, so this is a situation. I will explain more on the data normalization later, and maybe a few weeks after this. Okay. So this is you can read, this is some discussion on that exercise. For each relation, primary key must not contain nouns. Room is related to hotel through the attribute hotel number. Therefore, the hotel number in room should either be null or contain the number of an existing hotel. So in that case study, it will probably be unacceptable to have a hotel number in a room with a null value. And then next explanation, booking is related to hotel through the attribute hotel number. Therefore, the hotel number in booking should be either null or contain the number of an existing hotel in the hotel relation. Okay. All right. So that is for the relational model. Okay. The other terminology is views. Views. Pandangan. Kurang tepat lah. So views. View in the table. View for the database. So the base relation, a name relation corresponding to an entity in conceptual schema whose tuples are physically stored in a database. Okay, view is a dynamic result of one or more relational operation operating on base relation to produce another relation. Okay. So views is a virtual relation that does not necessarily actually exist in the database, but it's produced upon request. Jadi apa ni? The views ni macam the result after query. The result after query. Okay, so this is query. This is query. We are not learn query yet in the practical. This week maybe. Okay. This week. So this is a query. Select. Okay. Just now I also use example select all from student, right? This is a query. Query. Okay, this is a query. When you give the SQL such instruction, and when you click enter or go here, they will travel to the database and search. Okay, search. Then they produce the table form output. Okay, they will give you the view of that. So this is a view. And this is a virtual. It is not created, but it's virtual. When you stop the operation after when you change or you change the query, so the first previous query views is disappeared. Okay, so remember this is a virtual relation only. Does not actually exist. Okay, it's a list of result actually. Result from a query. So it's named as a view. Contents of a view are defined as a query on one or more base relation. Okay, and this is a dynamic, meaning that changes made to base relation that affect views attributes are immediately reflected in the view. Means that okay, we select select everything from table student. Table student currently have 1, 2, 3 student. Okay, and then you make a query, then this is what they show to you 1, 2, 3. But after that, some new information is inputted. Okay, number 4, student number 5, and that moment you recall back the query select all from student. Then now the view will change. Okay, so it changes is has something to do or reflect or with what has been added to the database or changed the database. Okay, same goes. For example, we remove. Okay, somebody remove the information number 2 and 3. So when you call the made a query select all from student, yeah, the views will also have only shows you the record 1, 4, and also 5. Okay, the same. They should show what they found in the table itself. Okay. The purpose to provide powerful and flexible security mechanism, hiding parts from database from certain users. And this part, hiding parts of database from certain users. Now you student, okay, you create the table. You create the table. Okay, so this is a database administrator, for example. They create the table, but this is a customer or user, other user. They won't see the whole of the database like you, administrator. Okay, they just see part of it. So that's why they create these views. Same like us. Okay, you open the browser and then you made a query. Find me a database book, recent database book. So the engine will process the query and just list down the result. Okay, so on the view of user, they can just see what is searched from the database. Okay, they cannot see everything. Okay, unless they change the query itself. So it permits user to access data in a customized way. So that same data can be seen by different users in different ways at the same time. Yeah, simplify complex situation. Also, you can update the views. All updates to a base relation reflect in a views that reference that base relation. If it is updated, then underlying base relation should also reflect the change. Okay. But there are restrictions on types of modification that can be made through the views. Updates are allowed, updates are not allowed. If you are involving multiple base relation, and also updates are not allowed if it is involving aggregation or grouping operation. Okay, usually updates are allowed if query involves a single base relation only and contains a candidate key. Okay. All right. So yeah, maybe you get boring with this kind of definition of terminology, the jargons and so on. Okay, but I do need to explain to you these various terminology. Okay, and after that, when you are using this keyword, you know what it is actually. Okay, later on, we will work on the views, the query itself during the practical usually. Okay, so you know, oh, this one is this. What is a constraint? You know constraint. This is the constraint. This is a referential integrity. So this is the query. This is what and what. Okay, even though this lecture is a bit maybe difficult for you to follow, but please try. Okay, then we have also the classes of views. Okay. Right. Last part on this chapter, that is a relational algebra and relational calculus. I'm not going to teach you algebra and also calculus, but I do need to explain to you the relationship between this mathematical theory to the DBMS. Database in the database. Okay. So the relational model RM is a method for organizing data that adheres follows to a structure and language consistent with the first order predicate logic. Actually, relational model follows two mathematical theory. The first one is relational, okay, or relation. Second one is a first order predicate logic. Okay, predicate logic. You will learn this one in class what? AI. This one is algebra calculus. So in this case, DB database has implemented or applied the mathematical theory in it. The two theory is relational theory and also first order predicate logic. In this case, all data is represented as tuples that are arranged into relations. So this is why they name it relational model. Relational model. Okay. So it is inspired from the mathematical algebra theory. So they name it as a relational model. So in that relational theory, they do form the data in matrix, right? Matrix and in a set of relation. So all data here is represented as tuple that are arranged into relation, and a relational database is one that is structured according to the relational paradigm. So the relational model's goal is to offer a declarative method for specifying data and queries. And this is the goal, the aim. Users directly state what information the database contains and what information they want from it. And let the DBMS describe data structures for storing the data and retrieve back the procedures for responding to the queries. Okay. Now from the week 1 until now, we learn data definition, right? We create a model like this for student table, for lecturer table, class table, and many more example. And after this, we'll go with the data manipulation. In the data manipulation, actually we query to the data. Okay, we query to the data. So what is this? This is a retrieval procedure. We want to retrieve back what the data kept in the database. So when we are doing the retrieval, they need some algorithm to retrieve. It is not easy for the machine to retrieve like us. We human people, how you retrieve the information? You go, you check, you open it one by one using your vision, using your logic and so on, and then you find the information when it is matched. Okay, but for the machine, how do the machine does not have a vision, machine does not have a brain to think. Okay, so they use the steps, procedures or algorithm. So that's why they follow, for this case, they follow the relational standards. Okay, theory. So a relational database is a collection of tables which mathematically are called relations. Okay, so the relations is math help to give a way of establishing a connection. So first they establish a connection between two or more objects or entities. Okay, and then a relation describes the relationship between two entities or objects that are usually represented as an ordered pair, input output, x and y, elements from the set. Okay, so relation here have several applications, especially in the computer science, that they create a RDBMS, relational DBMS. This one, you learn this, right, in the mathematics class. What is this? This is an arrow diagram. How do you make connection between first and second object x and y? Okay, they put a pair. So this arrow shows a connection between x and y, and it will form a pairs of x and y. Then the same things can be represented using a tabular form. So this is what your database look like in tabular form. So when the input and output of a relation are expressed in the form of table, now it is named as a tabular representation of a relation. So this is the history why database is named as a relation under the relational model. Okay, so a relational database store data in series of tables so that the data models mathematical theory of relation. So that the data models a mathematical theory of relation. Means that this is the real situation. They have a data, and then they form this relation table, okay, to organize the data. So it means that they models the data using mathematical theory of relation. Okay, and the model you created allows for queries. Again, queries is not as simple. Yeah, the simplest query is select everything from table. Select everything from table. But sometimes, not sometimes, many times, users can ask many things. Select this. Oh, no. I want all student name Ali. So what? So that is the queries. Okay, queries. So how do the database do this retrieval? How do they find out the result from this query? I only want the student who the weight is ranges from 40 to 60 kilos. Is that simple, you think? This is not simple. So you must go back to the mathematical relation. So they apply back the projection, the selection, the join, okay, and other operations and connect it the data in the tables by ways of keys. So that's why the keys is important thing in defining the table and also database. Okay. This is like how mathematics is related with the database. Okay. So this is for your reading. You can read. Later on I will change the notes in the author. This one is new. Okay. Addition. Okay, and the rest, this is the product used for the projection and so on. Okay, so this is actually how do they apply the Gaussian product, okay, in the relation, and then all of this has something to do when we are doing query and join later on. Okay, join the tables. Okay, to find out the result, what is required by the user. User can ask many things. Like I said before, they do not simply ask for all. They do need ask the database to find them certain certain values based on various conditions. Okay, so they goes how they relate this one, or how do they apply the mathematical relation in their searching. Okay, look at this. 5 basic operations in relational algebra they use in database. That is a selection, projection, Gaussian product, union, and also set difference. So this perform most of the data retrieval operation. Okay, data retrieval operation. Also we have a join, intersection, division operation, and many more. Okay, but basically the 5 basic is used. Okay, so this is what we learn today. Basically we learn about the entity relationship, its history, what's made up for the entity relationship, how it differs ER with object oriented, how it differs, and then the terminology we have, then what else? The ER modeling, we have 2 types, but later on we will learn more on the next topic, that is entity relationship modeling. So next week, please stand by with a pen and paper, and then you can follow me to draw the things, to draw your entity relationship modeling. Okay, right. So that's the end of our lecture today. Okay. I hope you can grab some, as much as possible, knowledge in this topic. Basically, yeah, you can see that it's like a repeating information, but they do related to each other. So every time I need to remind again the definition, the situation, or the anything that is related to one specific issues or text or definition and so on. Okay, do you have any question?